To build the Great Pyramid of Giza, ancient engineers had to extract, transport, and stack 2.3 million individual blocks of stone. The smallest of these weigh about 2.5 tons. The largest weigh up to 80 tons. They achieved this 4,500 years ago. They had no wheels, no pulleys, no iron tools, and no modern heavy machinery. For decades, pop culture has filled that technological gap with the image of endless lines of enslaved people dragging these stones across deep, dry desert sand. But pulling a multi-ton sled across dry desert sand creates a specific physical problem. The sand piles up in front of the runners, creating a mound that eventually locks the sled in place. There is also a geographic hurdle. The Nile River, the primary route for heavy transport, currently flows miles away from the pyramid sites. Dragging these blocks overland for that entire distance would require a workforce larger than the archaeological evidence suggests existed. New data from satellite radar and fluid dynamics is now providing a different explanation for how these materials actually moved. This research suggests the Egyptians didn't rely on sheer force, but rather a logistics network that utilized the physics of water. The logistics began at the quarries. While the limestone for the pyramid's core was local, the high-quality outer casing came from Tura, and the massive granite blocks for the interior chambers were brought from Aswan, over 500 miles to the south. In 2024, researchers used SAR satellite radar and deep soil coring to look beneath the modern agricultural fields. They identified the Ahramat Branch, a now extinct 64-kilometer tributary of the Nile that flowed directly past 31 different pyramid complexes. We have administrative records of this water network in use. In 2013, archaeologists discovered the Diary of Merer, a logbook written by an inspector 4,500 years ago. Merer led a crew of skilled boatmen. His logs detail how his team loaded dozens of 3-ton blocks onto barges and floated them directly to valley temples, which functioned as active river harbors. This river branch changed the transport requirements, reducing the overland dragging distance from several miles to just a few hundred meters. However, even a few hundred meters of desert presents a challenge. A 2.5-ton stone block would still cause a sled to sink into the sand. A wall painting in the tomb of Jehuti-Hotep shows a worker standing on the front of a sled, pouring liquid onto the sand. For years, this was described as a ritual purification. When physicists tested this action, they found it was a specific mechanical technique used to change the friction of the sand. Adding 2 to 5% water creates microscopic capillary bridges. These droplets act like glue, binding sand grains to create a stiff surface. This prevents sand from mounding up, reducing the required pulling force by 55%. This technique allowed a coordinated team of 20 to 50 men to move stones that would otherwise be immobile on dry desert ground. The final challenge was the height. Workers had to lift these multi-ton blocks hundreds of feet into the air. Most experts agree that the Egyptians used a system of ramps, both external and internal, to drag the majority of the stones to their final positions. But research at the Step Pyramid of Djoser suggests the Egyptians may have also used water as a lifting force. Researchers mapped a massive dry moat and a stone enclosure nearby, identifying them as a potential water treatment and purification facility. The theory suggests engineers funneled this purified water into a vertical shaft inside the pyramid. Filling the shaft would raise a massive wooden float. When the water was drained, the descending float acted as a counterweight, pulling a separate platform loaded with stone up to the next tier. If confirmed, this system shows that the Egyptians could use water pressure to perform heavy lifting from the center of the structure. The emerging scientific evidence shows the Giza Plateau was less an empty desert and more an interconnected industrial port. The Ahramat River Branch provided the highway, moisture control managed the friction on land, and internal shafts potentially handled the vertical lifting. The construction of the pyramids was supported by a logistics network that moved millions of tons of material with high efficiency. By utilizing the specific physics of their environment, from river currents to the molecular behavior of wet sand, the Egyptians successfully engineered a solution for a project of impossible scale. As science fills in the gaps, it shows that the pyramids weren't built by a simple application of force, but by a highly repeatable system of mechanics.